Feel like cross multiplication is more complicated than it needs to be? Well, in this video, I'm going to show you a completely different way to do it. One that's faster, easier, and not the way most teachers explain it. Stick around, and by the end, you might just prefer this method over the traditional one. When cross multiplying, each denominator moves diagonally across the equal sign, becoming the numerator on the opposite side. And the same for the numerator. It moves diagonally to the other side and it becomes the denominator.
So let's start working with these questions to understand what I mean.
So here's x over -2 equals 7. 7 is over 1, so 7 is the numerator. And the denominator, which is -2 on the left side, is going to cross the equal sign. And when it crosses, it's going to go to the numerator, which is 7. So we get x equals 7 times -2, which is -14. So the second one, we have 39 over x equals 3. And you realize that 3 is over 1, so 3 is the numerator. And x is in the denominator. Now, this is kind of a sticky situation. We don't like x being on the bottom. But you know what you can do? You can cross the x to the numerator, which is the 3, and the 3 could cross to the denominator on the other side. So you'll end up with 39 over 3 equals x. Again, the 3 will go where the x is, and the x will go where the 3 is. And then we have 39 over 3 equals x. And x equals 13.
Now, how about when it's a little bit complicated like this? Same thing. I want to isolate the x. Remember, this is what I want it to be by itself. So it wants to stay on the left side by itself right there. So to solve for x, you want to isolate x. This 5 is on the bottom. It goes, crosses the equal signs, goes to the top. The 2 crosses, goes to the bottom. And that could be done in one step. So you have 15 over 20. And therefore, this will end up being reduced by 5, reduced by 5. So 5 goes into 15 3 times, 5 goes into 20 4 times. So you end up with x equals 3 over 4. Okay. Now, how about here? So here, again, just you want the x to be by itself, but the x here is on the bottom, so we don't want it to be on the bottom. Can I do all of this in one step? Yes, I can. As long as you know, if you're crossing the equal sign, if you're on the bottom, you go to the top, and if you're on the top, you go to the bottom. You could do everything simultaneously. You want the x to go there, and at the same time, you want the 3 to come where the x is, and you want the 8 to go there. So now watch this. This becomes 8 times 9 over 2, which stays there, and the 3 comes where the x is, so times 3 equals, and the x goes to where the 3 is. So all of this is done in one step. And now, if you want to like reduce from here, you could go 2 goes into itself once, goes into 8 4 times, and 3 goes into itself once, goes into 9 3 times, and 3 times 4 is 12. 12 over 1, or x equals 12. So here's 2 more questions that I'm going to do. Now, cross multiplying, you want to isolate for the x. Here is x plus 2. What you want to do in this one here, you just want to cross the 4 only right now. So x plus 2 equals 36. 4 times 9 is 36 over 6. Now x plus 2 equals 6. Move the 2 to the other side. Becomes x equals 6 minus 2, which equals 4. So very quick. Now here, the x is on the bottom. So remember, I said these have to exchange places, and the 2 goes right there. So now that will give me 30. And the 3 will come where the x minus 1 is, and the x minus 1 will go where the 3 is. So when you cross multiply, you cannot say, I'm going to cross multiply the -1 by itself. No, you can't. If you have to cross multiply the whole thing in here. So now this gives me 10 equals x minus 1. Move the -1 to the other side. It gives you x equals 11.
And that's it. Cross multiplication doesn't have to be confusing when you use this method. If this helped you, make sure to like the video, subscribe for more math tricks, and let me know in the comments, did this method make more sense to you? Thanks for watching, and I'll see you.